All right, example 5, that of a vertical asymptote here. This is a useful thing to keep in mind when doing limits, and this is the payoff of plugging in. So if we go ahead and plug in, we're going to get 9 over 0. So we land into the category of a non-zero number divided by 0. And this always means that there is a vertical asymptote. So in this case, there's a vertical asymptote at x equals 2. That's what this means. So what we want to do now is actually use some intuition and or numerics to help us figure out what we're going to write. Because we're either going to write, right now there's 3 possibilities. The 3 possibilities are positive infinity, negative infinity, or DNE. Because remember, with an asymptote, you can either both go up, in which case the limit equals positive infinity. Both one-sided limits can go down, in which case the answer is negative infinity. Or your one-sided limits can be opposite. They disagree. One goes up, one goes down, in which case DNE. So we just need to figure out what the one-sided limits are doing. So here's where it's really useful to think of doing our limits here. So here's our axes. We don't actually have to have a great picture here, but we know there's a vertical asymptote at x equals 2. So now, things we could plug in, right? We could plug in a value like 1.99 and maybe a value 2.01. So now notice what's going to happen here is when we plug in this 1.99 into the bottom, because all we really care about is the sign, whether it's positive or negative. We don't actually care what the number is. We know it's a vertical asymptote. We know it's going to go either up or down. So whether or not we get, positive 40,000 or we get positive, 3.10297, as long as it's positive, we know that the trend is going to be to positive infinity, and we're just going to make sure we plug in a number that is sufficiently close to 2, like a 1/100th off or something like that. You don't want to plug in like negative 30 because, maybe, there's a vertical asymptote here, but maybe, the graph does something weird before that. So make sure it's close to the asymptote. So if we think about this, what happens here is in the bottom, we'll get 1.99 minus 2 squared. And if we plug in 2.01, what do we get? Well, for the left-hand side, we just get negative 0.01 squared, which negative squared is a positive. And on this side, we get 0.01 squared, which is positive. So in each case, we get a positive number. So we know that on our graph, it's going uphill. And you didn't have to actually do these calculations here, because we could see from the original writing that there's a square here. So as long as we're sufficiently close to 2 here, we're going to get, actually no matter what we plug in other than 0, we're going to get a positive number. So we know this has to do something like that. Now, of course, if this numerator were negative 9, then while the denominator is positive, we would still multiply by that negative 9, in which case our answers would have to change appropriately so. So in this case, they both go up, so we can conclude that this whole limit here is actually just positive infinity.